Alright, for the last problem of the reverse engineering track, we have Goland. So it's a hardcore challenge. Don't feel bad if you don't succeed. Oh, don't worry, I don't feel bad at all. So you will need to use all that stuff you learned from the previous challenges. You can use Gydra, maybe a supplementary plugin will be necessary. And there's other tools like IDA free, etc, etc. So we have bus.zip here. Let's see what it contains. Bus.zip. So we have a bus right here. Let's look inside of Gydra. So one thing I did before starting this video is I installed the plugin here. It's called Go Tools. So basically, Go uses a different way of calling functions than the standard way in x86 with using a specific register for the first, the second, the third parameter to a function and then using the stack. I don't know the exact details. Well, Go decided F that, I'm gonna do it my own way. And it's not for a bad reason, because they support more features like returning multiple values from functions and stuff like that. So they had their reasons, but it makes stuff more difficult to reverse engineer since it doesn't follow the standard. But thankfully, some smart people wrote a plugin for Gydra called GoTools. So if you want to install it, you can either go to GoTools and look at the GitHub. No, that's not it. So Gydra GoTools, this one. So you can follow the instruction to install it, or if you're using a Arch-based distribution like Manjaro for me, you can install it directly from the Arch user repository. So I installed it from there and now it's available in the extensions. You just go here, install, and check it. So it's gonna make it easier to decompile, but it's still pretty nasty, I think, personally. So where did it go? I think I remember, yeah, okay. So what's up, boss? We have to change this to go here to tell it it's a Go program. And then it's gonna take a while because I don't know, it goes nasty. I don't mean it in a bad way. Is there a good way? I don't know. Is it done actually? No, look, it's running right here. Yeah, because I think Go doesn't use dynamic libraries or whatever. It's all bundled in the binary, so the binaries are bigger. I think, I'm curious actually, if we do file bus, that doesn't give us the size. So bus is 1.9 megabyte, while another similar binary is going to be a few kilobytes. So yeah, it's definitely bigger. So this problem I had so much trouble doing, because as you'll see in a few seconds, there's so much stuff that's unnecessary and unreadable even when you have a nice decompiler that shows you in the pseudo C style and not the pure x86 code, you know. So it's not exactly clear what the code does, and on top of that there's a pseudo cryptography happening on the user input to find out the flag. So you have to figure out how that works, but that can be done pretty easily with a few smart guesses, I guess. And then you need to actually attack the algorithm, and for that you can automate it, but I did it by hand, so it took me so long. I'm probably gonna do it by hand and maybe show you how it's done and then get to the end, but you'll see. I didn't take the time to write a script to automate it, because you need to instrument GDB and Takes some time, or maybe I'm just being lazy, but that's okay. So in Go, like the main isn't like the main you would find at the top level. It's called actually main.main. Because why use main when you can use the main? So a bunch of crap we don't know what it's used for here. Some random functions without names. So pew var1 is undefined star 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 long star in fn. So this is all the crap you need to ignore, because if you have no idea, like, it doesn't help you at all. Oh yeah, another thing that's really annoying is like all the strings are Unicode, so like you won't see them like inside the code. Like here you can see like a pointer to like the Unicode, but like it's so hard to like understand. So I tried doing this in Anger as well. So since I didn't even know the output that was printed when it was a success, it was hard just to find that. But you can find it out with strings and or just like grep. I don't know. Now let's try doing it legit. So OS this std out. So it's like some IO routines. I think we can ignore it. I think this is like the main part. Yeah, okay, so we have a call to main that stuff here. And I have no idea. This is not used, so it's probably unnecessary. And local 18. It's here, it's worth 1. You can find all the references. Local 118. So it's never overwritten, it seems like, unless like no, it's passed by value. So it seems it's always equal to 1. What about local 110? So I have a hard time believing it's never overwritten, right? And no idea like where this is used. So yeah, it's pretty crappy. Let's look at main stuff. So I don't think that's so long. And you have some recursivity in there. So like when I was solving this for the first time, I was looking at this and pretty sure like there's some decode rune. I think it's like some Unicode stuff. Like I couldn't find like too much useful information. Like here is like the only thing I think I found that is useful to like understand the algorithm. So bvar, like I'm not sure what it was, like it's being casted to a byte and like it's being dereferenced, so like using an actual byte, and it's checking that it's between those two values, right? So if we look at what those two values are, so 0x60 is that all? Is that it? Yeah, so it checks if this is smaller than, like, if you know your ASCII table by heart, you know that 97 is A and 123 is gonna be something like after Z, right? Yeah. But everything in between is going to be A to Z, so it's your lowercase alphabet. So checking if bvar is in the lowercase alphabet range, and then it's doing this right here. So plus AC is 712, then it's taking it modulo 18, so 26, the size of the alphabet, plus 61, so A, so it's bringing it to A. And I'm curious to see, yes, so 172 modulo 26 is 16, so actually you can just do it plus 16. So my guess with this, it's doing like a ROT16 on the flag and compares it to the user input, right? Or actually it does a ROT16 on the user input and compares it into like with a flag that it stores somewhere in the binary, and like good luck guessing where, right? Maybe we could like try doing a ROT16 on like the term flag, right? So if we take f equals to flag, and for C in F we can do like print the car of ord C plus 16. That's probably gonna break if we go out of bounds. So let's just like find a, we can go on CyberChef actually. CyberChef is one of the coolest tools to know when you're doing CTF, because you have all the tools you need for data manipulation. So ROT, you can take this one, change it to 16, and just take flag. So we know this is the start of the flag, right? So if we find that pattern inside the binary, there's a lot of stuff up there. So we string and grep it's not that easy, is it? So it's probably like encrypted or something, so we can just read it off the binary and decode rune. I don't know if there's some crypto stuff, so but that's fine. We can just use GDB and like figure out where it's being decoded, right? So break main.main. Actually, since we know the core logic is in main.stuff, we can break in main.stuff, right? And if we want to save in more time, we can like find the address of this here, but it's not like the same address as in GDB, so but we can like keep track of like the instructions. So main.stuff, yeah, so run. Now it's gonna ask a flag, a test, so yeah. Let's just, oh yeah, so when stepping through like the binary and go, like if I just do next, it's gonna like do nothing and do some weird stuff and jump all over the place. But if I do SI, it's gonna like act more normally, but still sometimes it's like blocking and jumping all over the place. Okay, so here we have compare 61, compare 7a. So this is this if here that is checking if it's within the alphabet range, right? So let's keep going, this is fine. So this is a comparison that we really care about. So if we check at the rotate 16 of, wait, is it rotate 16 or 13? 14, 15? Because it's an S, right? 16, maybe it's 10. What? I think I messed up something then. So AC. All right, because A is gonna start on 97, right? So 97 modulo 26 is 19. 19 plus 16 modulo 26. Is that correct? So it's rotten 9 actually. Still not the case. Let's take the complement. So 26 minus 9 is 17. Still not the case. So what's alphabet then? So A, B, C, D, E, F, G, H, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So we know F maps to an S, right? Wait. do I do this? Yeah, okay, so what's the rotate value on this? So 14. This is not how you're supposed to do it. 13? It's just a rat 13? I probably messed up somewhere, but synth. Let's look for synth. It's probably not gonna work. But I want to be sure. So there is a syntax error. Yeah, okay, this is not. Okay, there's so much crap here, and none of it is what we want. Maybe it was a little bit ambitious with my query. So this is strings inside of. Yeah, it's not gonna find it. So now we're sure. So yeah, it's doing rat 16. So if we take like, this is the expected value for the character. So we entered flag, so it's gonna match the first few values. We can break here, and now we can continue, and we can leak like each character like this. So y, and we're gonna get the, here we have a 4, and 4 are ignored. So right, we can like reverse this. So flag like this, and keep stepping like that. So we're gonna get like a, yeah, you failed it. So basically we just do the same thing, enter flag and like some bunch of crap. Continue. We can info breakpoints to go faster. We can delete the first one or the second one, I'm not sure. I think it's the first. Continue. Yeah, okay. So we get our S, Y, 4, T, dash, 7. So now we continue like that. So dash 7, XXX. So that's the input we have to use. And basically we just keep, this is what I did during the contest. We just continue doing this until we get the flag. So run, copy the flag. Now I'm gonna lower the font a little bit. Continue S4. When there's a mismatch between our character and the flag's character, we just note it down. So here there's an H. Just keep doing that. Yeah. Blah blah blah. Continue. So we have n, here's an underscore, put the underscore. And I don't know if I really want to do like all the characters because the string is quite long, but you can keep doing that until you reach like, wait. So I'm gonna break, so bus, flag, tu es trop. think that's the flag. Something like that. Maybe I have it somewhere in... Okay, no, I don't have it. Whoa, what's going on? Okay. So we can like build on top of that. Like imagine like I just did it. It took me a while, like at least half an hour. I'm not gonna bore you with that. Run next. So now we just want to jump to the compare, right? Where am I? Check. Yeah, because SI is step into, so I'm jumping. I don't get out. I'm running in circles. It's a very Anyways, I'm gonna end it here. I know it's not satisfying, but I showed you how to leak like one character at a time by like breaking on the compare where the characters are compared with the flag characters, and just doing a rut 13 on the input. Well, the flag's character to know which one you're supposed to input. Thanks to this logic here. Yeah, a little bit messy, I know. I do my best. Thank you for watching. See you next time.